Okay, test corrections. This one here, right? Alright, test corrections. This is chapter 8. Number 1, basically all you had to do was graph these polar coordinates, 2 and 3 pi over 4. And so I'm just going to draw the graph here. This is my radius of 1, 2, 3, 4, 5, and 6. Okay, a little off, but we'll go from there. So the radius is 2, and we're at 3 pi over 4. This is your pi over 4 here. 3 pi over 4, 5 pi over 4, and 7 pi over 4. So we're at 3 pi over 4 at radius 2. So right there, that should be point A. And then your next one is negative 6, negative pi over 4. So let's go to negative pi over 4, which would be this direction to right there. And we're at negative 6. So 6 would be right here. Negative 6 takes you the opposite direction. So this is where B is at. Any questions on that? All right. And then the next two were really to kind of make sure we understood how to find our degrees. So 7 pi over 3, 6 pi over 3 is 2 pi. 6 over 3 is 2. So 6 pi over 3 goes around to 2 pi, and then another pi over 3. So this is a 60-degree angle here, which would be, this would be all the way around, and there would be 7 pi over 3. And we're at radius of 5. That is point C. And then the last one is negative 4, 13 pi over 6. 12 pi over 6 is 2 pi. So 12 pi over 6 goes all the way around, and then another pi over 6, that's a 30-degree reference angle. And it's negative 4, so 1, 2, 3, 4, but it's negative means you go the opposite direction. 1, 2, 3, 4. And that is where D is at. That is how you do the polar coordinates. How do you feel about those now? A lot of you missed the last couple. All right, that's number 1. Let's take a look at number 2. Number 2, rectangular coordinates, so 4 and pi over 6. We want x and y. So on this, for 4 and pi over 6, there were some things that we were given, x being r cosine of theta. X equals r cosine of theta, y equals r sine of theta. You are also given x squared plus y squared equals r squared, and the tangent of theta equals y over x. You're also given the polar form from complex, but we'll get to that here in a little bit. So here's the thing. We did x and y, we are given r and theta. Well, here's r and theta for both x and y. We want the actual values. We don't want the equation, the actual values. So that means we need to be able to pick one of these things where we have all but what we need. So r and theta for x and y here are the ones we're going to use. So x equals r, which we don't know, right? X is r cosine of theta. Y is r sine of theta. And r is 4. And then we got to find theta by putting pi over 6 in to these positions. Now we can find x and y. So pi over 6 is a 30-degree reference angle. And what is the x value at 30 degrees? What's the x value? Radical 3 over 2. So I'm going to take 4 times radical 3 over 2. That reduces to 2 radical 3. That is my x value of my coordinate. Over here, what is the y value of pi over 6? 30 degrees. 1/2. So 4 times 1/2 is 2. And that's your y value. That's your coordinate that you were looking for. Not too difficult, was it? Again, it's not that you're incapable. You're just not making a connection. All right, moving on. Number 3. Number 3. 3 is given the rectangular coordinates. What is the polar coordinates? So we need to find r and we need to find theta. Again, using these values up here. To find r, if I have x and y, I can use this equation. Well, I do have x and y. And the problem that I saw on the test is that most of you didn't know how to do this. When you squared that and you squared the y, you take the square root because that's what that r is. Take the square root of both of those. X squared plus y squared equals r squared. So I took the square root to get r. 3 squared is 9. The square of a square root is just the number itself. Radical 3 times radical 3 is the square root of 9, which is 3. So we have 9 times 3 is 27, and negative 3 squared is 9. So it's the square root of 36, which is 6. So there's your first part. R equals 6. All right, now we need theta. And we're going to use the tangent of theta equals y over x. Since we have y over x, we can get theta. Again, tangent of theta equals the y value, negative 3, over the x value. The 3 is reduced to 1. So here I have the tangent of theta equals negative 1 over radical 3. All right. And I told you that these are your numerators of those 3 fractions of your unit circle. So this is a negative 1/2. This is radical 3 over 2. Y is your short leg and it's negative. X is the long leg and it's positive. So on the unit circle, we're down here. This is your x-axis. So where is that at? That's at 11 pi over 6. So 6 and 11 pi over 6 would be my polar coordinate. Any thoughts on that? Okay. Number 4. Number 4 is convert y equals 5 to a polar equation. Now look, if I'm looking for an equation, I'm not looking to get the values of what's in that equation. So polar equation needs to have r, it needs to have theta in it, not the coordinate. So I'm not finding r and I'm not finding theta. If I want the equation, I just want the equation that has those variables in it. So what do I know about y? Y equals r times the sine of theta. There is r and theta. I don't need the values. Y equals 5. So 5 equals r times the sine of theta. That is okay, but it's not really far enough. What we want to do is get r by itself. A lot of times in our rectangular equations, we want y by itself. So it's the same type of thing. So I'm going to divide off the sine of theta. And so r equals 5 over the sine of theta. And what is 1 over the sine of theta? Cosecant. So really 5 times the cosecant of theta equals r, and that was the actual answer. Again, notice I don't have any values for r and theta. When I'm looking for the equation, I just want the variables. So I'm just manipulating. There's no calculation here. All right, and then look at number 5. Number 5, I'm converting r equals 7 to a rectangular equation. So I want x and y. I don't want the values of x and y. And you were shown that x squared plus y squared equals r squared. Here is the x and the y. All I need is the value of r, which I have here. So x squared plus y squared equals 49. So remember, when you're looking for an equation, you're not looking for values of those variables. You're just manipulating. And that was the easy one, remember? A lot of you messed that up. All right. Number 6. Number 6, sketch the graph of r equals the cosine of theta. This was a kind of hard one because just like on our pretest, it was going to be a completing the square problem. And you were going to solve it this exact same way. I can't do anything with cosine of theta. I don't have the value of theta. I can't do anything with r. But if I can multiply both sides by r, I see that r times the cosine of theta is just x. And I need to make this as a rectangular equation. So again, x squared plus y squared equals r squared. R squared is x. So x squared plus y squared equals x. Subtract the x off, and I get x squared minus x plus y squared equals 0. And now we can complete the square. Completing the square is half of the b coefficient. The b coefficient is -1. So 1 over 2, I'm going to square it. When we square it, the negative goes away, it becomes positive. And I have to add that to both sides. 1/2 squared is 1/4. This becomes a perfect square trinomial that factors into x minus the 1/2, quantity squared, plus the y squared equals 1/4. So this is a circle with the center at 1/2, 0. So if I make these 1s, there's 1/2, 0. My radius, this is r squared, so r is just 1/2. The square root of 1/4 is 1/2. So my radius is 1/2. So it's a very tiny circle. That's all we needed to do. Alright? Any questions on that? Let's take a look at number 7. 7 I'll go through quickly. At the end of this, if you want to take a little more time on it, I'll take a little more time. Number 7 is filling out the chart. What you have is r equals the sine of 2 theta. I told you guys that really you need to take 2 times theta first and then find the sine. So when you're doing corrections, that should have been the first thing you did. Pi over 2, if you look at pi over 2 times 2 is just pi. Many of you did that wrong. The sine at pi, the y value at pi is 0. So at pi over 2, we're back at 0. And when theta is 0, 2 times 0 is 0, we're still here. So we go from here out somewhere and back in. When you do pi over 4, theta is pi over 4, 2 times pi over 4 is pi over 2. The y value of pi over 2 is 1. So somehow we go from 0 out to 1 and then back again to 0. And if you filled out your chart, you saw that you had some points here. But most of you screwed up by pi over 2, you put 1 here because you didn't take 2 times pi over 2. And so you went from here to there somehow. But if you did it correctly, you got a flower petal, and that was the same as you went around the circle. So that's really what it was going to end up looking like. We can come back to that, and I can do some more values for you at the end if you want. Let's look at number 8. Number 8, almost everybody got this right. 6 minus I. A is 6 and B is 1, -1. B is the coefficient on the I. So 1, 2, 3, 4, 5, 6, -1. That was A. B was at 9 plus 5I. Again, A is 9, B is 5. So 7, 8, 9. 1, 2, 3, 4, 5. There's B. C is at 1. That's 1 plus 0I. 1, 0 is C. And 0 plus -4I. 0, -4. That's D. If you missed any, it was usually just one coordinate. Okay, 9. One plus I, we have to convert this to polar form. Polar form is r times the cosine of theta plus I times the sine of theta. Okay, so we got to find r. R is the square root of a squared plus b squared. 1 squared plus 1 squared. B is the coefficient on I. Most of you put I in there. B is the coefficient. That's where you made a mistake. So R is just the square root of 2. The issue now is finding theta. Well, A and B are your x and your y. A is 1, B is 1. That's at 45 degrees. So pi over 4. We did a ton of these on your pre-test. That was the answer. That's all you had to do. Number 10 is a little harder. 10 is radical 3 plus I. Again, B is 1, the coefficient on I. So R, again, is the square root of radical 3 squared plus 1 squared. And again, the square of a square root is just the number. That's where we made a mistake. Square root of 3 times the square root of 3 is the square root of 9, which is just 3. Plus 1. Square root of 4 is 2. So 2 times the cosine of theta plus I times the sine of theta. Use the tangent of theta being y over x, or b over a. That's 1 over radical 3. Again, these are your numerators of your unit circle. That's 1/2 over radical 3 over 2. Short leg, positive. Long leg is x. You're at a 30-degree reference angle, pi over 6. Knowing your unit circle is extremely helpful on all of this. By now it should have been mastered. Okay, number 11. Sketch x equals 6t minus 4 and y equals 3t and eliminate the parameter. Well, to eliminate the parameter, we divide by 3. I'm going to choose this side. And t equals y over 3. So I'm going to substitute that in to the x equation. 6 times y over 3. Oops, minus 4. The 6 and 3 reduced to 2. So x equals 2y minus 4. Put it in slope-intercept form. I get x plus 4. Divide off the 2. So y equals 1/2 x. And 4 over 2 is just 2. Goes through the y-axis at 2, up 1 and over 2. That's all you had to do there. Any questions on that? Okay. Number 12 was a little harder. X equals 2 cosine of t and y equals 3 sine of t. Well, again, here to eliminate your trig functions, we're going to add these two together, because if I square both sides, I'll get a cosine squared and a sine squared. And if I have cosine squared plus sine squared, those get eliminated because they're equal to 1. So if I square both sides, this is what I get. I'm going to divide off these coefficients and add the two equations together. So x squared over 4 plus the y squared over 9 is going to equal the cosine squared plus sine squared, which is 1. Your trig functions are gone. This is not a circle, it is an ellipse. Your x value is plus or minus 2, your y value is plus or minus 3. So that's what you get for your graph. You could have done a t-chart, but you needed to use pi values because the t is in the degree position. Pi over 6, pi over 4, pi over 3, and just keep going, and you would have got these values on your graph like that. But you have to go all the way around to get them all. So your best bet would have been to eliminate your parameter, your trig functions first. But it's okay. If you would have done all these points, you would have got it all right. Again, I can come back to that here in a minute. 13 should have been a no-brainer, but we struggled with it. I need the parametric equation given these 2 points. So the parametric equation is x equals x sub 1 plus t, and y equals y sub 1 plus the slope times t. Well, the x part's easy. X sub 1 is 3. That was easy. The y should be easy. Y sub 1 is 7. We need the slope. So 2 minus 7, the y value is subtracted over the x values. That's negative 5 over 5, or negative 1. So m is negative 1, so that's just minus 1 times t. And that was your parametric equations. Those were. Those should have been easy for you. So those are the corrections to the test. I'll take some questions if you have them.